that. And now we are going to learn the simulation of characteristic of Zener diode. But as usual, first we need to log in to our account. After that, go to Physical Sciences. And scroll down until you find the solid state. And then choose the characteristic of Zener diode. Yeah, you can see here, as usual, there are theory, procedure, simulator, assignment, reference, and feedbacks. We're going to simulator. Okay, to enable the flash player, you go here and then allow it, and after that reload the page. And then we'll wait until the simulator shows up. Okay, so here is the simulator, but before we get started, we need to know what are these variables means. Okay, so here there are insert key is used to insert key on a switch connected with battery, and there are choose Zener diode, which used to select different Zener diode that having different Zener voltage. And then there's series resistance. Here we can directly put the series resistance value. And then there are rheostat value that we can control by using this slider over here. And then there are load resistance. This is the value of load resistance, can be set or changed by using this slider over here. And there are reset button, which is to reset all the connection. So after that, we're going to connect all of here. And then how to make connection in this simulation is click one end node of the battery and drag it into the next position where we want to connect the wire, just like shown in the figures below. You can see that on a procedure here. We're dragging this node. We're dragging this node over here, and then then after that goes there. You can see the connection from the diagram that show in a procedure. There. there you go. If the connection are correct, insert key option is activated. This, and then okay, so now we're going to start this simulation, and then first thing we do is to choose the Zener diode, which is, for now we're going to choose 5.6 voltage, and then for the series resistance we're going to put 1000 there, and then for the rheostat value we're going to we'll stay in 1000, and then for load resistance we're staying 0. So the value that comes out here, we're going to put it on a table, and after that we're going to decrease this from 1000 to 975, and then for the load resistance we're going to increase it until 500. And here is the value. You can see here there are voltage series resistance, which is 0.1968 volt, and then current through series resistance, or IS, is the same but in milliampere, and then IL is the same value but in milliampere as well, and then the IZ is 0.000 milliampere. And after that we're going to decrease the rheostat value from 975 to 950, and after that the load resistance we're going to increase it until 1000. So as you can see here on a voltmeter, their value is 0.29304 voltage, and then the IS is 0.2930 milliampere, and then the IL is the same, and then the ISZ is 0.000 milliampere. For the next step is the rheostat value. We're just gonna decrease it to 925, and then the load resistance we're going to increase it to 1500. So the value that comes out over here, we're going to put it on a table like we do before, and then we're doing it until the rheostat value hits the 0, and then we're doing it until the load resistance is 20,000. So this is the result from our last simulation, and then as you can see here, for example, we can see that the rheostat value is 925, and then the load resistance is 1500, and then this is the result. As you can see here, the VS is, the voltage Z series is 0.35028 volt, and then the IS is 0.3503, the IL is the same value, and then the IZ is 0.000 milliampere. And if we look in a table here, this is the example that we choose, 925, and then the load resistance is 1500, and then the result is the same like we got in the simulation earlier. So for the RH, or you can say rheostat value, we're going to do the simulation with decreasing the value to 0, but for the load resistance we're going to increase it until 20,000, and then you can see here the graph. Here's the graph. This is for first bias, and then this is for forward bias. Sorry for that. Okay, here it is. You can see the difference between these two. So that is all for now. Thank you for watching.